let's finish this problem. Recall that we have y double prime equal to 2 times the quantity 2 sine squared of x plus sine of x minus 1. So this quantity in parentheses, you notice that that's a polynomial expression in terms of sine. So if you make a substitution, let u be equal to sine of x, we actually have 2u squared plus u minus 1. And of course what we want to do is factor that expression. So I want to factor 2u squared plus u minus 1. Well, that factors as 2u minus 1 times u plus 1. So y double prime we can write as 2 times 2 sine of x minus 1 times sine of x plus 1. So the work that we do is very similar to the work that we did with the first derivative. So we're going to solve 2 sine of x minus 1 equals 0. And also we have to solve sine of x plus 1 equals 0. And keep in mind that x is still between 0 and 2 pi. So 2 sine of x minus 1 equals 0. That amounts to sine of x equals 1/2. So you have to remember your unit circle. When is sine equal to 1/2? It's equal to 1/2 when x is equal to pi over 6, or when x is equal to 5 pi over 6. Sine of x plus 1 equals 0. Well, that amounts to saying sine of x is equal to -1. So that gives us x is equal to 3 pi over 2. So we found a potential points of inflection. Now, remember, a point of inflection happens whenever the second derivative changes from positive to negative or negative to positive. So remember, we're from 0 to 2 pi. The values of x that cause the second derivative to be 0 are pi over 6 and 5 pi over 6. So what you can do now is use some test points. 5 over 6, 5 pi over 6, and 3 pi over 2.